Wind and Water Becoming Current by Zoe Gleason. In this video, you can see a straw being used to create circular rotations among the red dots. The straw demonstrates equatorial winds. The red dots seen in the video represents gyres. The gyres, or in this case, the red dots, are moving in a circular direction. The straw pushes and deflects surface water, which creates currents. This causes the red dots to spin and rotate, as seen in the video. The gyres, or in this case, the red dots, move in a clockwise direction. The ocean currents are deflected to the right, which is shown in the video. This is a model of how gyres work. Well, what exactly is a gyre? A gyre is a system of rotating currents. A gyre is formed when global wind patterns forces are created by Earth's rotation and Earth's land masses. Wind drags on the ocean surface, causing water to move in the direction the wind is blowing. Gyres circle large areas of calm water. Debris and garbage drifts into these areas due to lack of momentum. Debris can gather for years. In the northern hemisphere, ocean currents are deflected to the right. In the southern hemisphere, it is the opposite. The ocean currents push to the left in the southern hemisphere. The North Atlantic Gyre is one of the 5 main gyres. The North Atlantic Gyre starts with the northern flow of the Gulf Stream along the east of the United States. The Gulf Stream is the western boundary current of the gyre. The gyre then turns into the North Atlantic Current. It flows across the North Atlantic to Europe. The gyre still flows in a circular pattern. The current flows south as far as the northwestern coast of Africa. There are 5 major ocean gyres. They are the North Atlantic Gyre, South Atlantic Gyre, North Pacific Gyre, South Pacific Gyre, and the Indian Ocean Gyre. Gyres affects almost everyone's lives. Debris ends up in gyres, and debris gathers up for years in gyres. Fish and seabirds digest the debris. If a small fish digests the plastic debris, then a larger fish eats a smaller fish. Then the human eats the larger fish. That means we are actually digesting debris, because if we eat a larger fish that eats a smaller fish that eats the garbage, that means that we could actually be digesting debris. The relationship between patterns of global winds and ocean currents are that global winds is that they determine the climate and weather. Convection, which is a transfer of heat between liquids and gases, which occurs between the air and ocean waters, giving the air varying degrees of temperature. Global winds creates ocean currents. Surface ocean currents are so closely linked to the global winds that once you know the pattern of global winds, you know most of the major ocean currents as well. An example of this is a gyre. A gyre is an oceanography, is a large system of rotating ocean currents and that are involved with large wind momentum. Ocean currents are formed by global winds and ocean currents, and global winds helps create a gyre. The blue lines shown at the bottom of the photo is a great example of an ocean current that is not blocked by any continents. This is the east wind drift. As you can see, there aren't any continents blocking the ocean current. It moves west to east. This is because it is further away from the equator. This also makes the currents colder. The east wind drift seems to move around the Earth over and over again. It moves in a counterclockwise motion. This is because the current isn't affected by an unbalanced force, which in this case is the continents and land masses. See, if there were land masses there, then the ocean current would curve like these ones. There also aren't any gyres here because there are no land masses blocking the currents to create a gyre. There are gyres here because there are land masses creating a gyre.